Okay, so for the following circuit, we have to find VO of S using Thevenin's theorem, and then find the value of VO at when t is equal to 0 and when t is infinity, and then find the formula for VO of t. So we're told to assume the initial condition is 0. Okay, so that's the first thing we're going to get jotted out. So we know I of S is equal to 10 times the unit step function, because that's what it said in the equation. And we know the Laplace of this would just be 10 over S. Okay? The Laplace of this will just be 5 ohms. The Laplace of this will be 5 ohms. The Laplace of this will just be the S times the inductance, so just 2S. And we're told to find VO of t using the Thevenin's equivalent. So this is what we're going to do. We're going to first find the Thevenin voltage. So we have a current source here, 10 over S. So this is 2Ix. This is 5 ohms. We have an inductor with 2S, current passing through here, called Ix. And this area, we do an open wire. So we're trying to find V Thevenin of S through here. So since this is an open wire, Ix will be 0. So that means this whole, region is pretty much useless. And since Ix is 0, this is 2 times 0. So this dependent voltage source is giving 0 volts. So we can just replace it with something like this. So pretty much V Thevenin will pretty much just be the voltage at this region. So we see I will just be moving like this, okay? Because current here will just be 0. So to get the voltage here, we just times 10 over S times the resistance, which is 5. And you should get 50 over S. And that's your Thevenin voltage. Okay, so that's the first part done. Now let's get Thevenin current. So to get Thevenin current, instead of including the resistor, we're just going to replace it with a closed wire, and the current passing through here will be I Thevenin. So this was 2S. There's a current Ix here. So what we're going to do is we're going to do a mesh analysis. So we're going to call this I1, and we're going to call this I2. So right off the bat, we see I1 should be equal to 10 over S. So that's the first thing we've got down. I2, it'll be 5 times I2 minus I1, minus 2Ix plus 2S I2. And we see I2 should be equal to I Thevenin, but we also see I Thevenin is also equal to Ix. So this will pretty much just be V I2 minus I1 minus 2 I2 plus 2S I2, and I1 was 10 over S. Okay, so let's FOIL this out more. Alright, and let's get like terms. So that's 3 plus 2S I2, and let's bring this to the other side. So it'll be 50 over S, and I2 is pretty much just 50 over S times 3 plus 2S. Okay, and this is equal to your I Thevenin. And now we have enough information to find the Thevenin resistance, or Thevenin impedance in this case. It's pretty much going to be your V Thevenin over your I Thevenin. So your V Thevenin was 50 over S. Your I Thevenin will be 50 over S times 3 plus 2S. This cancels out, this cancels out. So this is just 3 plus 2S. Now we're going to write a Thevenin circuit. The Thevenin voltage, recall, was 50 over S. We have a Thevenin resistance load of 3 plus 2S. And then recall, we remove this section of the wire. So we will include that. Okay, so this is Vs, and it's 5 ohms here. So to solve for, VO of S, and to solve for VO of S, we can do the following. We know 50 over S should be equal to the total impedance. So 3 plus 2S plus 5. And this is going to be your current, right? Now, and then this is times by your current. So the current passing through here, pretty much. And then your VO of S will pretty much be equal to 5 times the current. Okay? So we just have to find the current, and then we can find VO of S. So let's isolate for I. So it'll be 50 all over S. Then obviously we add the like terms up. So 5. So it'll be 8 plus 2S. Let's factor out the 2. So it'll be 4 plus S. And then we have a 2 here. This turns into 25. And this is your I value. And we can put that into here. So it'll be 5 times 25 all over S times 4 plus S. So this just becomes 125. Hold on, let me double check that. Yeah, okay, 125. And now we can use partial fractions to solve for this. Okay, and times everything by this value. So it'll be 125 equals A S plus 4 plus B S. So when S is equal to minus 4, your B should be equal to minus 31.25. And when your S is equal to 0, your A should be equal to 31.25. So your VO of S will be equal to 31.25 over S minus 31.25 all over S plus 4. And we just take the inverse Laplace of all of this. And this should give you 31.25 minus 31.25 e to the power of minus 4t. So this is your VO of t. And to find VO at 0, we just plug in 0. So this becomes 31.25 minus 31.25. And that's just 0. And then VO of infinity, that's 31.25 minus 31.25 e to the power of minus infinity. This cancels out into 0, so it's just 31.25. So yeah, these are your final answers.